Hello, my name is Hyun and this is the review of the week 3. When the channel length is getting shorter, there will be some problems. The problems is called short channel effects. I'm going to explain about short channel effects on today's video. So the first problem is called punch through. Because of the PN junction structure, there will be depletion area between source and body and drain and body. We can neglect when the channel length is long, but when the channel length is getting shorter, there will be some overlap area between the depletion area, so the electrons can move to drain, so it causes more current. It called punch-through phenomenon. This graph shows that when the channel length is getting shorter, the drain current is getting larger. So there is a 3 solution to prevent punch through. The first solution is we doped the body heavily. When we doped the body heavily, in theoretically, the depletion area will decrease and there will not overlap area. But however, when we dope the body more, there will be the fixed charge will getting larger in the junction boundary. It means that the electric field will getting stronger and the distance of the band will be closer and the mobility of the electron will be decreased. So nowadays we do not choose this method. Second is using buried oxide in the MOSFET. It is called the SOI structure and UTV SOI structure. By using the buried oxide layer, we can prevent the leakage path is made by physically, but there is some disadvantage that adding the buried oxide layer will be more cost, and because of the layer, the on current will be decreased too, and it cannot control the heat go outside. Third solution is using the heterojunction. That means we use the two materials that has different energy band. So we we made a quantum well by force, so we can control the funds through phenomena. The next phenomenon is called VT roll-off. When the channel length is getting shorter, there will be an overlap between the potential energy, and it causes the threshold voltage is getting low. So when we apply lower voltage than normal situation, the MOSFET will operate. It is called VT roll-off, and this graph shows that phenomenon. This graph is when the VDS is 0.1 voltage, but it is 2.5 voltage. And this energy band diagram explain too that when the channel length is short, when we apply the little gate bias, the electrons can move to drain and the current will occur. This is the equation of the threshold voltage reductions. And the third phenomenon is the drain-induced barrier lowering, called Dibble effect. When we apply the positive bias in drain more and positive bias more and more, the potential and energy level is go down, so it makes the barrier lower, so the electrons can move. And one thing we should know that Funch-through phenomenon and threshold voltage roll-off phenomenon and Dibble effect occur simultaneously at the same time. The next phenomenon is velocity saturation and mobility degradation. When the channel length is getting shorter, the applied electric field, the power of the electric field will be getting stronger, because the electric field unit is voltage per meter. So when the same voltage is applied and the shorter channel length makes the larger electric field. When the electric field is getting larger, there will be a velocity will be a saturation, and mobility is getting lower. It means the amount of current will be decreased. and this is the channel length modulation. Last week I explained about the saturation area. I said in the saturation area the current will be the constant, but that was in theory, but practically there it is not constant, and the current will be getting a little bit larger. So this figure shows why the current is getting larger. And next effect is Gödel effect. When we apply the high bias in the drain, the gate will feel that it has negative bias relatively. So when the channel length is shorter, I said the electric field will be stronger, and by the electric field, electron can move to other band. So it is called direct tunneling. And when we doped source and drain, there will be some defect, so there will be some trap sites. So there is no direct tunneling, but through the trap, the electron can move. Electron can move. Electron can move. So it is called trap assist tunneling. Because of direct tunneling and trap assist tunneling, on the offstate there will be some leakage current when only drain is applied some voltage. So this graph shows what is the Gödel effect, and when off current there will be a leakage current. And this is the phenomenon of the MOSFET breakdown. When the channel length is short, in the channel, the carriers that move the drain influenced by the electric field, and when electron is closer to drain, it will be accelerated by the electric field. So the energy that the energy of the electron will be getting larger. And electric field is the most strongest in the junction boundary. Junction boundary. And some carriers that have a larger energy is called hot carrier. The hot carrier, when the hot carrier conflicting with the depletion lattice, electron hole pair will generation. We have learned the avalanche effect and impact ionization in the fundamental of the semiconductor device. So a lot of electron will be conflict and generation. So hot carriers move to drain, body, and gate, so there will be a lot of leakage current. It is called MOSFET breakdown because MOSFET is not operate normally. So it has two solution 2. The first is the LTD is lightly doped drain. I said the power of electric field is most strongest on the junction boundary. So in order to reduce the power of the electric field, we lightly doped the parts of the junction boundary like this. So we reduce the electric field, the direction of horizontal direction of electric field. So we reduce the short channel effect. The next solution is called pocket implant. Look at this figure, and there the red area is added doping area with same polarity of body. So we doped heavily with same polarity of the body, and it makes depletion area. Depletion area is made on the body area. So it is called pocket implant. The last phenomenon is source drain series resistance. I said light doping drain called LDD is the method of the preventing short channel effect like this. And light doped means that concentration of the carrier is lower, and it means the resistance is getting larger. When the channel length is shorter, we cannot ignore the size of the resistor that connected by series, so there's no difference there's no difference of the current. It is called source drain series resistance. So it is the end of the review of the short channel effect. Thank you.